In the annals of military automotive history, few vehicles have been born of such immediate, desperate necessity as the mine-resistant ambush-protected class, and among them, the International MaxxPro stands as the towering archetype. The genesis of this machine lies not in a decades-long procurement cycle typical of the Pentagon, but in the bloody, dust-choked roads of Anbar province and the improvised explosive device belts of Afghanistan. During the early phases of Operation Iraqi Freedom, the United States military faced a grim realization. The doctrine of light tactical mobility, predicated on the speed and low profile of the high-mobility multi-purpose wheeled vehicle, had collapsed. The enemy had moved the battlefield underground, employing buried artillery shells and homemade explosives that turned the flat-bottomed Humvees into death traps. The solution required a fundamental inversion of engineering philosophy. Speed was no longer the armor was the armor. And thus the MaxxPro was conceived, a vehicle that prioritized crew survival above all else, sacrificing stealth, handling, and fuel efficiency to become a rolling bank vault capable of weathering the detonation of buried mines that would vaporize lesser machines. The MaxxPro represents a shift from the offensive maneuver warfare of the Cold War to the defensive survivability logic of counterinsurgency. It is a machine defined by its silhouette, a tall, ungainly, top-heavy fortress perched atop a commercial trucking chassis. Unlike the M1 Abrams tank or the Bradley fighting vehicle designed to deliver violence, the MaxxPro was designed to absorb it. It is a force protection asset, a term that clinically masks the visceral reality of its purpose. To ensure that when a 155mm shell detonates beneath the front axle, the biological cargo inside remains intact, even if the vehicle itself is reduced to scrap. To understand the MaxxPro, one must first understand the industrial compromise at its core. Unlike a unibody design where the armor and the frame are integrated, the MaxxPro is essentially a parasitic organism, a highly specialized armored survival cell grafted onto a mundane host. The foundation of the MaxxPro is the International Workstar 7000 series chassis, a platform ubiquitous in the civilian sector. In the civilian world, this chassis is the backbone of garbage trucks, cement mixers, and municipal snowplows. Navistar's decision to utilize a commercial off-the-shelf platform was a masterstroke of logistics, if not performance. By leveraging an existing production line, Navistar was able to scale production at a rate that traditional defense contractors could not match, delivering thousands of vehicles in months rather than years. However, the Workstar chassis was designed for vertical loads, the weight of gravel or refuse, distributed predictably along the frame rails. It was not originally engineered to carry a rigid, high center of gravity armored capsule while negotiating off-road terrain at combat speeds. The chassis utilizes a ladder frame construction, which is inherently designed to flex and twist slightly to absorb road irregularities. The armored crew capsule, by contrast, is a rigid box that does not flex. This mismatch creates tremendous stress at the interface points where the capsule mounts to the frame. In the field, this manifests as a vehicle that feels disjointed. The driver can feel the chassis twisting beneath the cab, fighting the rigidity of the armor above it. The use of a commercial chassis also implies that the automotive components, axles, differentials, and suspension hangers are located outside the primary armored citadel. In the event of a mine blast, these components are sacrificial. It is a common sight in post-blast assessments to see a MaxxPro with its entire front end, hood, engine, front axle, sheared off, while the crew capsule sits detached but intact in the crater. This separation is a feature, not a bug. It ensures that the kinetic energy that destroys the suspension is not transmitted directly to the crew compartment. The defining characteristic of the MaxxPro and the primary reason for its survival record is the V-shaped hull. In a flat-bottomed vehicle like the M113 or Humvee, the shock wave from a mine blast strikes the floor perpendicular to the surface. The energy is absorbed by the plate, causing it to deform inward and transmitting a lethal vertical impulse to the occupants, often shattering spines and legs even if the hull is not penetrated. The MaxxPro's hull acts as a wedge. When a blast wave hits the V shape, the angle of incidence forces the high-velocity gases and debris to deflect laterally, venting the energy out to the sides of the vehicle rather than absorbing it directly. For this deflection to be effective, the hull must be elevated significantly above the ground to allow the blast wave to expand before contact. This requirement dictates the MaxxPro's towering height, which creates its most significant operational liability: a dangerously high center of gravity. The physics of the V-hull are unforgiving. To survive a 7-kilogram TNT mine blast, the vertex of the V must be the lowest point of the crew capsule, and the sides must slope steeply upwards. This geometry creates a cramped interior floor plan where the V intrudes into the cabin space, forcing the crew to sit with their legs elevated or straddling the transmission tunnel hump. This ergonomic sacrifice is the price of keeping the floor from becoming a lethal projectile. A unique engineering choice in the MaxxPro is the method of assembly for the armored capsule. Unlike many military vehicles where the hull is a single welded monocoque structure, the MaxxPro's armor plates are bolted together. Designed in conjunction with the Israeli firm Plasan Sasa, this modular approach initially drew skepticism. Critics feared that the bolts would shear under the intense pressure of a blast, turning into deadly shrapnel inside the cabin. However, the bolted design has proven to be a logistical brilliance. In the grinding attrition of counterinsurgency, vehicles are frequently damaged but not destroyed. A welded hull that takes a hit from an explosively formed penetrator or an RPG often requires depot-level repair, involving cutting torches and specialized welding that ruins the temper of the armor steel. The MaxxPro's bolted panels allow for field repairs. A damaged side plate can technically be unbolted and replaced with a spare at a forward operating base, returning the vehicle to service in days rather than months. Furthermore, the bolted joints act as a friction damper. Under the extreme stress of a blast, the microscopic movement between plates can dissipate energy that would otherwise contribute to structural failure. The sheer scale of the MaxxPro is difficult to convey without standing next to one. The base model measures approximately 254 inches in length and 102 inches in width. But it is the height, often exceeding 120 inches, that dominates its physical presence. This height makes the vehicle a massive target for RPG gunners and creates substantial clearance issues in urban environments with low-hanging power lines or bridges. The weight varies by variant, but a fully combat-loaded MaxxPro typically tips the scales between 37,000 and 45,000 pounds. This mass, concentrated high above the axles, dictates every aspect of the vehicle's performance, from its sluggish acceleration to its perilous handling in corners. The dash variant was specifically introduced to shave weight and lower the profile slightly to address these concerns, but the fundamental physics of a top-heavy armored box remain inescapable. The motive force required to push 20 tons of steel through desert sands and mountain mud is provided by the MaxxForce engine family. This choice of power plant is perhaps the most controversial aspect of the vehicle's design, representing a collision between commercial emission regulations and military reality. The MaxxPro utilizes the MaxxForce D 9.3i6 engine, a 9.3-liter inline-six, in the Dash and Plus variants, and the slightly smaller D 8.7i6 in the original base models. These engines are turbo diesel units producing between 330 and 375 horsepower and roughly 1,250 pound-feet of torque. While these figures are respectable for a commercial dump truck, they are marginal for a combat vehicle of this weight, resulting in a power-to-weight ratio of roughly 18 to 20 horsepower per ton. The MaxxPro's engines are infamous for their reliance on advanced exhaust gas recirculation to meet emission standards, a strategy Navistar pursued aggressively while competitors adopted selective catalytic reduction with urea injection. In the civilian trucking world, this decision was a disaster, leading to massive reliability issues. In the military context, it created a unique set of vulnerabilities. The EGR system works by recirculating hot exhaust gases back into the engine intake to lower combustion temperatures and reduce nitrogen oxide emissions. This requires massive EGR coolers to lower the gas temperature before reintroduction. In the scorching heat of Iraq or Afghanistan, where ambient temperatures can exceed 120 degrees Fahrenheit, the cooling system of the MaxxPro is already stressed to its limit. The added thermal load from the EGR system frequently causes the EGR coolers to crack, leaking coolant into the engine cylinders. This can lead to catastrophic hydrolock or the disappearing coolant syndrome, where the engine consumes gallons of coolant with no external leaks. Furthermore, the heavy recirculation of exhaust leads to significant soot buildup in the intake manifold and the variable geometry turbocharger. The turbocharger vanes, designed to adjust boost pressure dynamically, often seize due to carbon fouling, resulting in a loss of power or turbo lag that can leave a vehicle stranded in a kill zone. The engine is essentially suffocating on its own exhaust, a problem exacerbated by the long idle times common in convoy operations. Despite the heat issues, the MaxxPro also struggles in the extreme cold, a relevant factor for its deployment in Afghanistan's winters and, more recently, Ukraine. The MaxxPro's engine features an ether start system for cold weather ignition. Unlike modern civilian diesels that might rely solely on glow plugs or grid heaters, the MaxxPro uses a measured injection of ether, a highly volatile starting fluid, directly into the intake. The starting procedure is a precise ritual. The operator must engage the ether switch for 2 to 3 seconds, then crank the engine. If done incorrectly or if the system malfunctions, there is a risk of damaging the engine or failing to start entirely. Once started in cold weather below 32 degrees, the engine control module automatically commands a high idle, revving the massive engine to maintain cylinder heat. This wet stacking prevention measure means a stationary MaxxPro in winter is a loud, vibrating beast, consuming fuel simply to remain operational. Mated to the MaxxPro's engine is the Allison 3000 series 5-speed automatic transmission. In contrast to the engine, the Allison transmission is widely regarded as the most robust component of the drivetrain. It utilizes a torque converter rather than a dry clutch, which provides torque multiplication at low speeds, critical for getting the heavy vehicle moving in deep sand or mud. The Allison 3000 is an intelligent transmission with Generation 4 or 5 electronic controls that adapt shift points based on load and terrain. However, it is limited by the physical realities of the drivetrain. The transfer case, typically a 2-speed unit, requires the vehicle to be completely stationary and in neutral to shift between high and low ranges. This is a tactical liability. If a convoy transitions from hardball road to deep mud while under fire, the driver cannot simply shift on the fly. They must stop, exposing the vehicle to attack, to engage the low-range gearing required to navigate the obstacle. The rotational force is transmitted to the wheels via massive steel drive shafts. These components are frequent failure points. The immense torque required to turn the heavy wheels, combined with the grip of the massive Michelin tires, places enormous shear stress on the U-joints and axle shafts. If a wheel is wedged in a ditch and the driver applies full throttle, a panic reaction common in ambushes. The drive shaft can twist or snap, immobilizing the vehicle. The differentials utilize air-locking mechanisms to provide traction, but these airlines are vulnerable to damage from underbody blasts or debris. Before we continue, I want to hear from you. Have you ever seen a MaxxPro in real life? Maybe you've worked on one, ridden in one, or just spotted one at a military base or museum? Drop a comment below and share your experience. And if you're enjoying this deep dive into military vehicle engineering, hit that like button and subscribe so you don't miss our upcoming videos on other fascinating machines of war. The suspension history of the MaxxPro serves as a case study in the rapid evolution of military engineering. The platform transitioned from a rudimentary setup that punished the crew to a sophisticated system that enabled true off-road mobility. The initial batches of MaxxPro vehicles, Base and Plus, were equipped with semi-elliptical leaf springs on solid axles. This suspension architecture was lifted directly from the commercial heavy truck world. While durable and simple to repair, leaf springs utilize interleaf friction to provide damping, which results in a harsh, jarring ride. On a commercial truck carrying gravel, the load is static. On a MaxxPro, the load is a top-heavy armored box that sways. The leaf springs provided poor roll control. When the vehicle hit a pothole or a rock, the solid axle transmitted the shock across the entire chassis, causing the vehicle to bounce violently. This head-toss effect was debilitating for the crew, particularly the gunner standing in the turret, who acted as the tip of an inverted pendulum. The ride was so rough that it caused physical injuries to soldiers over long durations and limited the vehicle's off-road speed to a crawl. Recognizing the mobility limitations, Navistar introduced the dash variant and the subsequent DXM upgrade kits. The DXM replaced the solid axles and leaf springs with a fully independent double wishbone suspension system using coil springs and high-capacity shock absorbers. This upgrade was transformative. The independent suspension allowed each wheel to move vertically without affecting the opposing wheel, keeping the chassis level and the tires in contact with the ground. The system offered up to 14 inches of wheel travel, allowing the MaxxPro to absorb terrain irregularities that would have previously launched it into the air. The improvement in ride quality reduced crew fatigue and allowed for significantly higher off-road speeds. Most importantly, the DXM suspension widened the effective track width and improved roll stiffness. This directly addressed the MaxxPro's tendency to roll over. By keeping the tires planted and controlling the body sway, the DXM system turned the MaxxPro from a clumsy truck into a capable off-road machine, earning the respect of drivers who had previously feared taking it off the pavement. Despite the mechanical improvements, the laws of physics still apply to a high center of gravity vehicle. To further mitigate rollover risk, the U.S. Army mandated the installation of electronic stability control systems on the MaxxPro fleet starting around 2014. This system uses sensors to monitor wheel speed, steering angle, and lateral acceleration. If the computer detects that the vehicle is entering a skid or is about to tip, it automatically intervenes by applying brakes to individual wheels and cutting engine power. This integration of computerized safety into a combat vehicle was a significant milestone. It acts as an invisible hand, correcting the over-inputs of adrenaline-fueled drivers. While some operators complain that the system intervenes too aggressively, cutting power when they are trying to power slide through a turn, the statistical reduction in non-combat rollover accidents validates its inclusion. The MaxxPro was designed for a specific war but has found itself fighting in another. Its operational history reveals the adaptability and the limits of the platform. In Iraq and Afghanistan, the MaxxPro replaced the Humvee for outside-the-wire missions. It excelled in the role of a convoy protection vehicle. Its sheer mass and armor provided a psychological blanket of security for troops who had spent years feeling vulnerable in canvas-doored trucks. However, the vehicle dictated tactics. In the narrow streets of Iraqi villages, the MaxxPro was a bull in a china shop. Its turning radius over 50 feet curb to curb made navigating tight corners impossible without three-point turns. It was too heavy for many rural bridges, forcing convoys to seek alternate routes or ford rivers, where its 36-inch fording depth was tested. The vehicle's size made it a magnet for insurgent fire, but its armor rendered it immune to small arms. Insurgents learned that shooting at a MaxxPro with an AK-47 was futile. leading to an escalation in IED size. The MaxxPro's survivability against mines became legendary. There are numerous accounts of vehicles taking massive underbody blasts that destroyed the suspension and engine, yet the crew walked away with only concussions. This survivability bred a culture of trust. Soldiers accepted the uncomfortable ride and the mechanical quirks because they knew the beast would die for them. The transfer of MaxxPro's to Ukraine introduced the vehicle to a peer conflict environment dominated by artillery, drones, and main battle tanks. The terrain shifted from the dry deserts to the deep, viscous mud of Eastern Europe. In the mud, the MaxxPro's weight is a liability. Without the DXM suspension and aggressive mud tires, the vehicle can sink to its axles, becoming a pillbox rather than a transport. However, when kept moving, the 4x4 system is surprisingly capable. Ukrainian forces have utilized the MaxxPro for medical evacuation and rapid troop transport into gray zones. The threat profile in Ukraine includes direct fire from tanks and anti-tank guided missiles. Surprisingly, the MaxxPro has demonstrated resilience here as well. Reports indicate MaxxPro's surviving impacts from T-72 tank rounds and RPGs that damaged the exterior but failed to penetrate the crew citadel. One documented incident involved a MaxxPro driving out of an ambush on 3 wheels, with the 4th dragging along the ground, a testament to the drivetrain's torque and the run-flat tire inserts. A new adaptation seen in the Ukraine theater is the integration of improvised electronic warfare systems. The threat of first-person view suicide drones is pervasive. Ukrainian crews have been seen mounting portable jammers onto the roofs of MaxxPro's. These systems create a dome of electronic interference to sever the link between the drone and its operator. This adaptation highlights the modular nature of the MaxxPro. Its flat roof and robust electrical system, despite its flaws, allow for the mounting of new defensive technologies that were not envisioned during its initial design in 2007. Life inside a MaxxPro is an assault on the senses. It is a cramped, noisy, and industrial environment designed for survival, not comfort. The interior of the MaxxPro does not feature standard automotive seats bolted to the floor. In a mine blast, the floor accelerates upward at thousands of Gs. If the seats were rigidly attached, this acceleration would be transmitted directly to the spine, causing fatal compression injuries. Instead, the MaxxPro uses blast-attenuating seats that are suspended from the roof or the side walls. These seats float above the floor. They feature energy-absorbing mechanisms, either crushable elements or hydraulic dampers, that allow the seat to stroke downward in a controlled manner during a blast event. This decoupling isolates the occupant from the initial shock wave. The seats are equipped with 5-point harnesses and head restraints to prevent whiplash, but they are notoriously uncomfortable for long durations, often described as sitting in a suspended torture device while wearing full-body armor. Access to the rear troop compartment is via a massive hydraulic ramp. In ideal conditions, a switch is flipped and the ramp descends. However, the hydraulic system is a frequent point of failure. Lines burst, pumps burn out, or the electrical signal fails. When the hydraulics fail, the crew must resort to the manual override pump located inside the rear cabin. Raising the heavy armored ramp manually requires a soldier to vigorously pump a handle for minutes, a physically exhausting task in the heat of combat. There are harrowing stories of crews struggling to close the ramp manually while under fire, or being unable to open it quickly to evacuate wounded. The side doors are also incredibly heavy, featuring combat locks that are essentially deadbolts, requiring significant upper body strength to operate, especially if the vehicle is parked on an incline. The electrical system of the MaxxPro is a multiplex design, utilizing the SAE-J 1939 CAN bus standard. This means that switches and devices communicate via digital data packets rather than direct wiring. While this reduces the amount of copper wire needed, it increases complexity. The wiring harnesses are routed through tight spaces, often rubbing against sharp armor edges or vibrating engine components. Chafing leads to intermittent short circuits that are nightmarish to diagnose. A short in a seemingly unrelated sensor can bring down the entire data bus, causing the instrument cluster to go dark or the transmission to lock in neutral. The system is also plagued by field modifications, soldiers splicing in inverters for laptops or unauthorized audio equipment using Scotch locks or twisted wires, which introduce noise and faults into the sensitive data bus. The MaxxPro is not a monolith. It is a lineage of vehicles that evolved to meet changing threats. The MaxxPro base was the original production model focused on blast protection using solid axles and leaf springs with the MaxxForce D 8.7i6 engine. The MaxxPro Plus was an up-armored variant with increased payload capacity, featuring dual rear wheels to support the extra weight, and an upgraded MaxxForce D 9.3i6 engine, still using leaf springs. The MaxxPro Dash was a lighter, more mobile variant designed specifically for Afghanistan. It shed roughly 4,000 pounds of weight, had a smaller turning radius, and was the first to introduce the independent suspension, later standardized as DXM. The MaxxPro Dash DXM is the definitive version, combining the lighter dash body with the fully independent DXM suspension. Most surviving MaxxPros in inventory are upgraded to this standard. The MaxxPro long wheelbase variant was extended to carry more troops or cargo, used as an ambulance or command vehicle. The extra length makes it even more difficult to maneuver in urban settings. The MaxxPro Recovery is a tow truck variant, equipped with a boom and winch to recover disabled MRAPs, built on the heavier Workstar platform but sharing the MaxxPro cab. The International MaxxPro MRAP is a study in contradictions. It is a technological marvel of blast deflection built on the chassis of a garbage truck. It is an engineering triumph that saved thousands of lives, yet it is plagued by mechanical gremlins that drive mechanics to despair. It is a vehicle designed for the defensive nature of counterinsurgency that has found a second life in the high-intensity offensive operations of Ukraine. It is not a perfect vehicle. It is overweight, underpowered, and ergonomically hostile. But its legacy is secured by the simple fact that it works. When the ground explodes, the MaxxPro brakes so that the soldiers inside don't have to. It is the beast that survives what tanks fear, a crude but effective insurance policy forged in steel and bolted together with the hope that everyone comes home. As militaries transition to lighter platforms like the JLTV, the MaxxPro remains a hulking reminder of a time when the only way to survive the road was